Hey everyone, and welcome back. We're going to be diving into some really cool new tech today. It's all about clean water and tackling those forever chemicals we hear so much about, PFAS.
Oh, yeah, those are nasty.
Yeah, they are. They stick around in the environment forever, it seems like.
And they could cause health problems, too.
Exactly.
Which is a huge concern with industries like, semiconductor manufacturing ramping up.
Yeah, it seems like that's only going to get worse. So today we're diving into some research from the University of Illinois Urbana-Champaign. These researchers may have found a way to actually get rid of PFAS for good.
For real?
Yeah, it's pretty exciting stuff.
Okay, I'm all ears.
So what's really amazing about this research is it doesn't just remove PFAS. This new tech actually captures them, concentrates them, and it destroys them all in a single process.
Wow, all in one go.
Yep. And get this. It even works on all different sizes of PFAS, even those super tiny, ultra short chain molecules that have been really hard to remove in the past.
Oh, yeah, those are tricky.
So to get us started, can you explain why those ultra short chain PFAS are so hard to deal with?
Okay, well, they're incredibly small to start with.
Right.
But it's more than just their size.
Okay.
Imagine trying to remove, specks of dust from a glass of water.
Okay, pretty easy.
Now imagine trying to remove salt that's dissolved in the water.
That's a lot harder.
Exactly. It was a totally different challenge. And those ultra-short-chain PFAS, they act a lot like salt. They completely dissolve in water and behave like ions.
Oh, okay.
Which makes them really tough to capture with the methods we've been using.
So it's like they're almost part of the water itself.
Pretty much.
So how did these researchers actually manage to trap these little guys?
Well, they had to get creative.
Okay.
They basically combined two different techniques: redox electrodialysis and electrosorption.
Okay. I'm going to need you to break those down for me.
No problem. So redox electrodialysis, that uses an electric field to separate ions based on their charge.
Okay.
Kind of like a molecular sieve that filters out just those PFAS molecules. Then they added electrosorption. Basically, they used super sticky electrodes that attract and hold on to the remaining PFAS molecules.
That's amazing. So they came up with a two-pronged approach that could grab all different sizes of PFAS. How did they actually make this work in a device?
Okay, so picture a three-part system. First, you have the desalination stage.
Okay.
And that's where the redox electrodialysis comes in. It zaps out those ultra-short-chain PFAS.
Got it.
What's key here is that they use a special nanofiltration membrane. This membrane doesn't get clogged by the PFAS like other types of membranes do.
Oh, that's huge.
Right. It's like a filter that stays clean even though it's trapping all those tiny contaminants.
Very cool. Okay, so step one, the ultra short chain PFAS are out. What happens to the rest of them?
Well, that's where those super sticky electrodes I was talking about come into play.
Okay.
In the second part of the system, they use carbon electrodes. And these electrodes are like magnets for PFAS. They capture all those remaining short and long chain molecules.
So they're basically cleaning up whatever's left over from that first step.
Exactly. And here's the cool part. As these electrodes capture the PFAS, they actually concentrate them.
Interesting.
Which makes them much easier to break down in the final step.
I was just going to ask about that. How do they actually destroy these so-called forever chemicals?
Well, the third part of the system uses something called electrochemical oxidation.
Okay.
They use electricity to break down the captured PFAS molecules.
So they just zap them?
Pretty much. And they're basically turned into harmless fluoride ions.
Wow. I mean, PFAS are supposed to be impossible to break down. That's why they're called forever chemicals.
I know, right? That's pretty incredible.
This is amazing. So how does this all translate to a cleaner world for you and me? What's the real-world impact of all of this?
Well, think about it this way. We could have wastewater treatment plants equipped with this technology so they could remove PFAS from our water.
That would be huge.
Right. Or even better, semiconductor factories could integrate this technology directly into their processes. Then PFAS would never even enter the environment in the first place. Oh, wow. So it's not just about cleaning up existing pollution. It's about preventing it from happening altogether.
Exactly. That's the ultimate goal.
That's a really powerful vision for a cleaner future. What other potential applications could this have?
Oh, there are tons. Remember those industries we talked about earlier?
Like textiles and firefighting foam?
Yep, and food packaging.
Right.
All those industries use PFAS.
So this technology could be a game changer for them, too.
Absolutely. The possibilities are really exciting.
This all sounds incredibly promising. But are there any limitations or challenges we should be aware of?
Well, it's important to remember that no technology is perfect.
That's true.
This is a huge breakthrough. But there are still hurdles to overcome.
Like what?
Well, scaling up any technology from a lab to an industrial level is always a challenge.
Right.
There are costs to consider, logistical issues, and then you have to optimize the process for real-world conditions,
Yeah.
which, as you can imagine, can be messy and unpredictable.
Guess it's not as simple as just plugging in a giant PFAS zapping machine. Haha. No, not quite. But remember how I said this technology concentrates the PFAS as it removes them?
Yeah.
That's a huge advantage. It means we're not just shifting the problem around, we're actually making those chemicals easier to break down for good.
Okay, so it's not just about removing them, but about getting rid of them permanently.
Exact.
That makes sense. So thinking bigger picture here, if this technology really takes off, what kind of impact could it have on the whole PFAS problem?
Well, first of all, it could change how we clean up the PFAS that's already out there,
Okay.
in our water sources like rivers, lakes, even groundwater.
So not just preventing future pollution, but actually reversing some of the damage that's already been done.
Exactly.
That would be incredible.
Right. And that's a huge win for the environment and public health. But it goes beyond that. Think about all the industries that rely on clean water.
Okay.
Everything from agriculture to manufacturing. They could all benefit from this technology.
Oh, yeah.
And let's not forget about our drinking water. It could be so much safer.
It's like a ripple effect, starting with clean water and spreading out to so many other things.
Precisely. And this is where it gets really interesting.
Okay, I'm hooked. What's so interesting?
Well, we've been talking about, the immediate benefits and, cleaner water and healthier environments.
Right.
But this technology could actually, spark innovation in ways we haven't even thought of yet.
Oh, how so?
Well, think about it. If we can actually remove PFAS effectively,
Yeah.
it opens up all sorts of possibilities for, using them in a controlled way.
Mm-hmm.
Because we know we have a way to clean up afterwards.
That's a good point. So we could almost unlock the potential benefits of PFAS without worrying about the long-term contamination.
Exactly. It makes you wonder, what other problem chemicals could we use if we had, really reliable ways to remove them?
That's a really interesting thought. So are these researchers just dreaming about the future? Or are they actually trying to make this happen?
Oh, they're definitely working on it.
Okay, good.
They're actively trying to scale up their tech, from the lab to real-world applications.
That's awesome.
Yeah. And they've even gotten the attention of some pretty big players.
By who?
The U.S. government wastewater treatment facilities, and of course the semiconductor industry.
Wow, that sounds like this tech is really on the fast track.
Yeah.
So let's bring it back to you for a second. Imagine a world where this technology is everywhere, it's just widely used. What changes do you think you would see in your own life?
That's a good question. Well, I think I would just feel a lot better knowing that my water was safe.
Yeah.
That it didn't have any of these harmful chemicals in it.
Right, peace of mind.
Exactly. But I think it goes beyond that, Think about all the things you use every day, the products.
Okay.
This technology could mean safer food packaging, more sustainable clothes, even better firefighting foam.
That's a lot of stuff.
Yeah, and all without that worry of, PFAS contamination.
It's amazing to think that something happening in a lab could change so much about our lives.
It really is, and it just shows how important it is to support this kind of research.
Absolutely.
And, breakthroughs like this, they don't just happen overnight.
Right.
It takes dedicated people, years of work, and a lot of trial and error.
Yeah, for sure. Okay, so to kind of wrap things up, it seems like this new electrochemical method for removing PFAS is a pretty big deal. It has the potential to solve a major environmental problem and improve public health. And the best part is, it's not just some far-off idea. Researchers are actively working to make it a reality.
I agree. It's really promising. And, even though we've been talking about semiconductors, this technology could have a much wider impact. It could help all sorts of industries and lead to a cleaner, healthier future for everyone.
I like the sound of that.
Mm-hmm.
This has been such an eye-opening deep dive. But before we go, I want to leave you with something to think about. We've been talking about all the amazing things this technology could do, but what about the responsibility that comes with it?
Ooh, that's a good point. As this technology develops and becomes more available, we need to think carefully about how it's used.
Yeah, I agree.
We need to make sure that it reaches the people who need it most, and that it's used in a way that truly benefits, the environment and everyone's health.
It's a good reminder that even with amazing breakthroughs like this, we still need to be careful and make good decisions.
Absolutely.
We need policies, ethical guidelines, and a commitment to sustainability to really make a difference.
Well said. And, this brings us back to you, the listener. What are your thoughts on all of this? What are you most excited about? What concerns you? We encourage you to keep learning and talking about this with others.
Yeah, it's a conversation we all need to be a part of. Creating a cleaner, healthier future is a team effort. We all have a role to play in understanding the challenges, discussing the possibilities, and pushing for solutions that protect our planet and everyone on it. Wow, this deep dive has been really something else. It seems like we're actually on the verge of a real breakthrough with this PFAS problem. And it's pretty incredible to think about how many things this could impact.
I know, it really is. For me, the most exciting part is the hope it gives us. For so long, these forever chemicals have just felt like this unbeatable enemy, this huge threat hanging over our heads.
Yeah.
But now we're seeing that we can fight back, we can find solutions, we can actually work towards a future where these chemicals aren't a constant worry.
It's a great reminder that even though we face some really tough challenges, human ingenuity and science can help us find a way forward. But like you said, it's up to all of us to stay informed,
Absolutely.
to keep having these conversations, and to push for these solutions that protect our planet and everyone on it.
I couldn't agree more. It's been fantastic diving into all this with you.
It's been a pleasure, and a huge thank you to all of you listening for joining us on this deep dive. We hope you learned something new, maybe sparked some curiosity, and hopefully you're feeling a bit of that hope we were just talking about. Until next time, keep exploring, keep asking questions, and keep diving deep into the fascinating world around us.